Okay, so chapter 4 test is problem number 1. You got to here just perfect when you distribute. Okay, the cosine pieces cancel out and you get 2 sine x sine y. Okay, but then you lost your half somewhere. I don't know where that went. And you can see when you simplified, I don't know what happened. It kind of went to crap on you. So when you do this, the 2's and the half cancel out and you end up with this. So that's one way to put it. Or, so you leave like that. Or instead of doing that, and a better way would be to say, what is this? This is sine 2x. Remember, it's a half sine of 2x. Okay? So that's the first one I noticed. Oops. Another one here that I noticed that was a little screwy was you really did a good job on most of these. There's just one or two that were a little weird. I'm trying to look at them on my other computer here. Oh, yes. Yeah, this one is just kind of weird, dude. I don't even know what you're doing here. It's kind of just like, what are you doing? This is the one where it's sine of the squared of x to the 4th, sine to the 4th of x, rather, sorry. Okay. So, of course, you're right. Of course, you're right. It is sine squared times sine squared, and you're not wrong by that. Okay. I did it like you. So, it's this times this. Okay. Now, that's true. Okay. Now, you can do this a couple different ways. It's up to you how you want to go about this. Totally up to you. So, what to remember is if you do the cosine of 2x, okay, what I'd rather not have, perhaps, is in other words, so when you get down here, we're trying to get to, so it is only a power of cosine, okay, just cosine. So in your answer, when you got to the end, it was cosine of 4x. It said just cosine of x is what it said. Now, you've got a cosine of 2x and a cosine of 4x in your answer, so that's not right, okay? Well, actually, technically, you could have gone a little further. That's all I was going to say about that. Is you could have gone a little further, okay? So it's possible you could do two things. It's not wrong what you did because I guess they just said first power. So I guess ignore what I said there. You could have done something a little different with that. But I read it again just now and it says first power, so that part's correct. Well done on that one. This one here is a little screwy. Where did it go? Right. So this one's weird. So this is the one where it says sine of x cosine x equals square root of 3/4, like that. What you need to do is remember that this is not what you wrote. You wrote that it is the sine of half x. It's actually the double angle. What you need to remember is that right there, it should be 2 sine x cosine x. So if it was 2 sine x cosine x, you would have the sine of 2x. You don't have the sine of 2x. You don't have this. You have a half of the sine of 2x. And then now you're off to the races, and you can solve the problem. You just had your identity a little screwy. And I think that was the only thing on number 4 that I saw wrong. Yeah. I'm going to open quiz 5 here real quick, and I'll run through that in a second. Chapter 5. Pause you while I look at it real quick. Okay, on chapter 5 test. On part 2 of problem number 2, I think it is. Yes. On part 2, only a goober, I mean, you did it right, but only a goober uses law of cosines to find that, okay? The law of sines would be the way to go on this problem, okay? So if I do this problem here, I say to myself, all right, law of sines, okay? And so I say to myself, all right, so it's the sine 54 over 12.92 you had, beautiful, is equal to the sine of c over 15.8, okay? Calculator at the ready. Let's do this in degrees, yep. So sine 54 times 15.8 divided by 12.92. Oh, yep, that's right, actually. Done. And I get 0.98. Now, if I take the inverse sine of that, now remember, there's two angles that this can work for, right? In theory, right? But it says 81 degrees. Well, I reject that, because if this angle here is 54, okay, and this side is 12.92, and this side is 15.8, what does that say about this angle? Well, it has to be bigger than 54. So what I do is I just take 180 minus this fella, and I get 98 degrees, which is what you had, but I think it's just an easier way to get there than doing that law of cosines calculation that you did. Totally. So on number 3, where you had all 3 triangles there, all 3 sides, this is a job for law of sines, and law of cosines, rather, and it right now, okay? Now, again, me personally, I wouldn't have solved for angle B, I don't think. I would have solved for angle A, because angle A is the biggest angle, and therefore you're guaranteed that that's the biggest angle, so when you use law of sines to do the follow-ups, you don't have to think about it, okay? You've already found the biggest angle. It can't be any other angles bigger than that one, okay? But that's just me. But first of all, that's the first thing I think, number 1. Number 2, okay, when I look at that, I know that angle B and angle A have to be very similar in size. Very similar in size. Why? Because they're very similar, and they're the 2 biggest sides of the triangle. They have to be, obviously, big angles. If the one's 25, obviously A is going to be a skosh bigger than that, but not much bigger than that, so it may be 30 degrees. Well, 30 plus 25 is, say, 55 degrees. That means that angle C, which is the smallest angle, would have to be, what did I say, 125 degrees. Well, that ain't going to work. Okay, but the reason you went wrong on this problem is where you said B equals, you wrote inverse sine. It's really inverse cosine, because you use law of cosines to do that. Does that make sense? So you screwed that up right there. This would work. Let's go ahead and bust this out. In theory, this works, I should say. In theory, this works. Trying to think how you use that. So then, yeah, that should. I don't know. Let's find out. So you had 21 squared equals 22 squared plus 16 squared minus 2 times 16 times 22 cosine. Oops, cosine of it. What did you do? Cosine of B, rather, right? So if I do this, it should be 21 squared minus 22 squared minus 16 squared over negative this, which will come out the same as what you have. It just looks weird. Does that make sense? It just looks weird the way you did it. But yes, it'll still give us the same answer. Okay, so but with cosine, it'll work actually correct now. So 16 squared plus 22 squared minus 21 squared. That divide by 32 times 22. Inverse cosine of that. I said give me an approximate, you hippie. 65 degrees. If this is 65 degrees, okay, well, that means this angle down here is going to be a skosh bigger. Not a lot, but a skosh bigger. So if I do that, the sine of 65 over 21 is equal to the sine of whatever this is, A over 22. So if I do this, to remember, just to pay attention to this here, I know it has just to be just a bit bigger than 65, because obviously it's just a bit bigger side, so it can't be too much bigger. And inverse cosine of that, oh no, sorry, inverse sine, you dumbass. Try again, inverse, come on. Inverse sine of that. There you go, 71 degrees. 72 degrees. Do I buy that? I totally buy that. So that's where you messed up. So you use inverse sine, but you did the cosine correctly. So just pay attention to that. And then look at your angle A. The way you did it, of course, your angle A doesn't make sense because it's the smallest side. It's across from the smallest side. It has to be the biggest angle, the smallest angle, and you gave it the biggest angle. So just be aware of that. Okay. So clearly that's correct. Everything else looks pretty good. I think on this problem, on this worksheet rather. This is test 5 again. Okay. Excuse me. This is interesting. They gave you the dot product, huh? Uh-huh. Uh-huh. There's your dot product, piece of cake. And I think we're almost there. Inverse cosine. Okay, so here we go. Here we go. Okay. So this one here, this is toward the end of the assignment here. Let's run through this one real quick. I think you're right. So number 8 is very close to what you have anyways. Here's a vector, -7, 8. Typically we write them like this instead of the way they did it there. It's kind of annoying. What's the angle between that and the x-axis? Okay, well, -7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. We're talking about this vector here. We want this angle here. Okay. Okay, so when I look at this problem here, I think, well, okay, it's not too difficult. So what I would personally do is I'd find this angle here because I'm lazy. Okay, you can do it a couple different ways. So you can do it a couple different ways. Like if you could just drop this down and you can go, all right, let's just do the inverse tangent of 8 over -7. Okay, and I'll do it this way first. If that's all you want me to do, that's what I would totally do. You with me? If you just gave me the option, this is how I would attack it. Okay, but here's the deal. I know this is the right answer. Oh, piddle. So 48 degrees, you're like -48, Mr. Groom, that's down here. That's right, it is -48. So what do? I add pi to it, or plus 180 in this case. 131 degrees. So this is 131 degrees. Okay, which is what you have. Well done. Now, the other way to do that, of course, would be to find an angle out here like so, which, yeah, 1, 0 is right, 1, 0. Okay, and then do the dot product, which you got -7 over the product of their lengths. Okay, a squared plus b squared, and then a squared, but this is 1. Product of those is 10.63. Inverse cosine is perfect. Well done, lady. Well done. Okay, use the cosine angle to find the actual angle between the two vectors. So what they want you to do is to actually do the cosine. So you're like, here's the deal. Basically, they want you to do the cosine. I did inverse tangent, okay? If you're weird and you want to, you're certainly welcome to do this as well. And you already found this should be 10.63, I believe. 49 plus 64 is 10.63. You with me? So if I do the cosine of this angle here, cosine of theta here, cosine of theta is equal to -7 over 10.63. And lo and behold, if you do that, oops, inverse cosine -7 divided by 10.63, 131 degrees. Same thing, right? It's just a different way of going about it. Making a difference to me. And so you did 113 instead. Well done on those ones. Yep. And yeah, that looks pretty good to me, kid. Well done. And then part 2 on number 8 is exactly the same procedure, exactly the same. And so the difference, of course, is just a skosh difference. But what we're saying is this: is if you had a triangle, if your triangle looked like so, we went. So remember, it's cosine. So we had -11. And then the hypotenuse was 62. So you draw that out here like this. Whatever, right? Because in essence, that's what we're saying. This is like 62, and this is -11 here. And I drew that goofy, didn't I? My picture looks crappy. I'm sorry. -62, or 62 length would have to be up here like this. Does that make sense? This is 62. This is -11. So the angle is here. If you take the inverse cosine of that, you get 100 degrees. That's all they want you to do is kind of draw that picture out. Up to you how you go about that. Just be aware of that. That's what they're saying to you in essence. Yeah. Another way to do this problem, of course, and I always show kids this in physics class, is that you put the x-axis where an x and y plane where you want to put the x and y plane. So 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. Okay, and -7, -7, 8, right? So here's our axes. Well, here's the deal. You said that this was 5.83 units long. I agree. Well done. Okay, well, if I brought that down, I could just as easily have written this so that this is 1, 2, 3, 4, 5 0.83 right here. Are you with me? Okay. So in essence, I could have put that all on the x-axis like that. Okay. And then it's just a matter of saying, well, what did you do there? Well, I rotated it basically down, right? So when you do these problems in the real world, if you had set it up, there's no, like, if you're like two people pulling on a dog or something, one's pulling this way and one's pulling this way, well, just line it up. So one of us is pulling right down the x-axis and the other one's pointing off toward Conoyers, and then it's just easier to deal with. And so that's kind of all they're asking you to do it. Then, of course, you rotate this one up the same angle, but it doesn't change the angle between them because they stay relative to one another. Up to you how you go about it, though. So that's how I like to do it. If I'm not given a bunch of mathematical stuff, I just said this guy's pulling this hard, and the angle between them is this. It's just easier to see. Well done. There's your dot product. What's the velocity of the plane? Oh, you did not do those last two? All right, that's good. Okay, so yep, there they are. They're vectors there, right? Okay, so those are they're vectors, but the idea is this: I'm flying. I forgot which way I was flying now. 200 north, like so, and the wind is blowing west. It's blowing towards the west, like so, which means I'm going to be blowing off this direction. So how fast am I going? Well, I'm going to be going 200 squared plus 23 squared, square-radicated. I'm going 201 miles per hour. Okay? And then it's going to say, what is the ground speed of the plane? Okay, I'm sorry. What is the velocity vector of the plane? It's this guy right here. Now, the vector has to have an angle, and it has to have a magnitude and a direction. So what I would personally do is inverse tangent 13 over 200. That's just me. That's what I would do. So we're going about 3.7 degrees. You could say that west of north. You could say north 3.7 degrees west. You could do, in a real compass situation, it starts at 0, goes around this way. 180 is south, back around to here. So 360 would be back north again. We don't say that. That just sounds ridiculous. So you just take 360 minus 3.7, and you could say that they are on a 356 degree compass heading or something to that effect. Okay, so that would be its vector. And then what's the ground speed? The ground speed is 201.3. And then basically I've already drawn that picture that they asked you to draw there. So that's cool. And then the last thing you wanted help with on this chapter 5 practice. Yeah, so it looks like you did a really good job on a lot of these ones. There was, I think, one that was a little screwy. Where did I see that? Excuse me. Yeah, ooh, good job not getting hung up on the radians on number 4. That was well done. Yep. Where did it go? I swear I saw one here somewhere. Oh, is this it? Is this it? Number 6. Nope, that's right. Sorry, I lied. I don't see your work on these, so I'll assume that you're right. So chapter number 8 through 10. Beautiful job of checking the second one. Beautiful job on that. I really appreciate how you learned that. That's nice. It's pretty easy to do when you think about it. Yeah, pretty straightforward there. And yeah, well done on number 10 as well. So yeah, you got a choice. It could be 66 or 113. Well done, lady. Well done. I swear there's one on here I thought was screwy, but I can't see it now. Well, piddles. So I think it all looks really good. And it's nice job on the 2 triangle bit, which is just screwy, and I hate it, but that's, whatever, I guess, is what it is. Linear combinations, very nice, very easy. Yep. Gosh, I swear there was something in here I wanted to talk about, but I don't see it. So nice work, lady. So I only see a couple that you had mistakes on. Guess give me any questions. Let me know if you have any questions on.